How does a self-driving car see the road? It doesn't have eyes, it has tensor. Millions of them following through a digital nervous system at the speed of light. And the secret of that nervous system isn't hardware alone. It's a piece of software called PyTorch. But to understand how PyTorch powers AI revolution, we have to go back 2 decades and rebuild math from the ground up, the roots from Lua Torque to PyTorch. In 2002, a library called Torque emerged. Written in Lua, it was powerful but rigid. Fast forward to 2016, a breakthrough year. Adam Paskey and the team at Meta did something radical. They rewrote Torque from the ground up for Python and they called it PyTorch. Today, it's not Meta's toy. It's a Linux Foundation, open source, free, and the backbone of modern AI. The language of reality is Scalars to Tensor. Before a car can drive, it needs a language to describe reality. That language is math, and PyTorch speaks it fluently using tensors. Start simple. A scalar is just a single number, like the car's current speed. String scalars together into a line. That's a vector in a direction. Stack vectors into a flat grid. That's a matrix, like a black and white image. But a self-driving car sees passes of a high-definition video. That requires multi-dimensional tensors. A data cube that holds height. A data cube that holds height, width, chiral channel and time all at one. The magic, CUDA, Autograd and dynamic graphs. A tensor that big would choke a regular computer chip. That's why PyTorch taps directly into NVIDIA GPU. Using a parallel computing platform called CUDA. CUDA turns thousands of GPU cores into a single massive brain. This gives PyTorch insane acceleration, turning hours of computation into milliseconds. Training neural nets requires calculus, millions of teeny derivatives. It runs Autograd, an automatic differentiation engine that traces every calculations and reverses it instantly to find the error. And here is the killer of Fisher. Old AI model used a static graph like a fixed railroad track. PyTorch uses a dynamic computation graph. It builds the model on the fly. You can change logic mid-run, debug like normal Python, experiment instantly. That flexibility is why researchers and Tesla engineers refuse to use anything else. From a single scalar to a 4D tensor, from a Lua script in 2002 to a dynamic graph, running on a NVIDIA GPU in 2026. This is how cars sees, not with cameras but with PyTorch, tracking the raw chaos of the world, compressing it into tensor, accelerating with CUDA, and driving the future one gradient descent at a time. PyTorch is free and open source and it's waiting for you. Install it and build something that sees the world differently.